right, we're going to skip session 2. So you might have come into this thinking we're following right along, but you actually need to be on book page 53. This is session 3. Session 2, we're going to do part of it together in class. Okay, but this is to develop finding the surface area of a three-dimensional figure. Oliver is using plywood to build the skateboard ramp shown. 3 sides of the ramp are rectangles. So 3 are rectangles. We can find area of a rectangle by doing base times height. Okay, how many square feet of plywood does Oliver need to build the ramp? Well, if you look at your picture, we have a 5-sided figure here. We have 3 rectangles and then we have 2 triangles. So I'm going to make a chart to help me. It is up to you how you solve this. I think a chart is a great place to start. Okay, so when we talk about that, we have a front, we have a back. That's 2 of our sides. Okay. We also have a bottom part of the ramp. We have a left and we have a right side. I'm just going to write S for side. Okay. You could flatten this out and try to make the net of that. I think it's making it more complicated in terms of making sure dimensions match up. It is up to you. So my front side is this right here. Well, I'm going to, okay, this front side here, sorry, some technical difficulty, is a rectangle. Okay, the front is a rectangle. So if I have the top of my ramp, you can call it the top, the front here is a 5 by 6. So I'm going to go down to my front and I'm going to put, it's a 5 by 6. Since it's a rectangle, I don't have to do a half, so area is just 30 feet squared. Okay, so that's my front. My back side here is going to be a 3 by 6 because this red dot here matches here. So it's a 3 by 6. It is still a rectangle. So base times height, 18 feet squared. Okay, my last rectangle is going to be my bottom that it sits on. It is a 4 by 6. It's another rectangle. So base times height, 4 times 6 is 24, 24 feet squared. Those are my 3 rectangles. Okay, it tells me that 3 of them are rectangles, so I did those first. My left and my right side are a little bit different, so be careful when we get to the triangles here. They're not identical. Okay, I'm going to erase everything so you can see it. Okay, so looking through here, oops, apologize for that. My first triangle here, my left side, is going to be a 3 by 4 triangle. Okay, but remember, my area of a triangle is going to be 1/2 of that, so 1/2 of 12 is 6 feet squared. My right triangle back here is 5 feet here, still 4 on the bottom, so it's going to be, I apologize, let me double check that, 5 feet for the side, that's my fault. My height is still going to be 3, and my base right here is 4. Okay, so my triangle over here, it is the same. Still a 3 by 4. So you're going to have a 1/2 times 12, which is 6 feet squared. So to find surface area, you have to find the area of every face and then add them all together. So you're going to add your 6 plus your 6 plus your 24 plus your 18 plus your 30. When you add all of that up, you should have 84 feet squared. So how you label these over here is up to you. I apologize for my confusion. I did this problem separately and I labeled them differently. So when I came over and tried to transfer my work, I was not matching up. So I was making sure that my dimensions were correct. Okay. But how you label them is up to you. If you want to call this the front here, the front triangle, instead of the front left, right, or whatever, it's up to you. Just make sure that you understand your labels and how they match. Okay, and I briefly mentioned this, and I think it'll come up later again. On the next page it does. So go ahead and flip over before I try to draw back to my table. If I look at these three top ones right here, three top, and I specifically look in this column right here, they all share a common factor of 6. 5 times 6, 3 times 6, 4 times 6. I can pull out the 6, and what do I have left? 5 plus 3 plus 4, or put in order, 3 plus 4 plus 5. What this means is I do 6 times 3, 6 times 4, 6 times 5, and then add them all together. Okay, we are at net here. On page 54, okay, they put the Explore problem back up here. Oliver is using plywood, we know that. Okay, talking about the 3 rectangles, 2 triangles. Okay, they give you some strategies here. The strategy they give is that you could draw a net to help you find the surface area. So the ramp has 2 triangles, so there's your 2 triangles. We know it has 3 rectangles, so there's a 1, 2, 3, and you can see the different dimensions of the rectangles that are labeled. Okay, model it. Another option is you can write an expression to find the surface area of a 3-dimensional figure. So use area formulas to write an expression for the sum is addition, so that word sum means you add, of the areas. This was more like the strategy I chose. You can see these are your triangles. So these are going to be your triangle 1, triangle 2, and then this one here, this one here, this one here. Those are all your rectangles because they do not have to be halved. Okay, it's always your choice in regards to that, how you want to solve it. You have some freedom as long as what you do makes the most sense to you, to your shape. And they're saying here, 6 feet, which other ones could also be labeled 6 feet. So go and spend a little. There isn't one right way to solve it. Okay, we're actually going to work through the connected problems on page, on page 55 together. Independent for this week is going to start on page 56, 7 through 9, and 1 through 5 on page 57 through 58. I want to make sure we actually discuss this whole page here. We're just going to do all the connected problems. So number 1, look at the picture. 2 line segments in the net are labeled as being 5 feet long. Where do you see these line segments in the prism? Okay, just like before, if you remember back to session 1, line segments are the edges. Okay, so when we're talking about what are line segments, what are the labels of 5 feet, whatever they may be labeled, those are the edges of your shape where 2 faces meet. Question 2, the length of one line segment in the net is labeled as 6 feet. Which other line segments in the net could be labeled as 6 feet? How do you know? Well, if you flip back, which ones do we think are also labeled 6 feet? All the vertical sides of the 3 rectangles. Okay? We know the opposite sides of rectangles are equal in length. So all the vertical sides of the 3 rectangles are also going to be equal in length. Remember, you can always pause at any point to make sure you have everything written down, then catch up. 3, Aisha wrote the expression 2 times 1/2 times 4 times 3 plus 6 times 3 plus 4 plus 5 for the area of the net. Explain why the expression represents the area of the net. Okay, we are not here yet. We have not talked about distributive property. So right now for question 3, I'm going to write a couple words here. We're going to talk about this question when you come back with me in class. This is called the distributive property. Okay, distributive property is when we can pull out the common factor and save it on the outside and multiply it by all the other factors that are left over on the inside. A lot of time on the distributive property, but for now I just want you to be exposed, and we'll talk more about that in class. Question 4, what is the area of the plywood Oliver needs for the ramp? Explain how a net can help you find the ramp's surface area. Well, we already solved this. We know it's 84 feet squared. Okay, how can the net help us? Okay, it can help us see all the separate shapes. So if you're struggling to picture what this looks flat, a net shows us all those separate shapes. Okay, it flattens out the shapes and lets you see them all. 5, how can you use what you know about 2-dimensional shapes to find the surface area of a 3D one? Okay, a 3-dimensional shape, guys, is made up of 2D shapes. So 3D shape is made up of 2D shapes. Okay, each face is a two-dimensional shape. So if you find the area of each 2D shape and add them together, you get your 3D shape. 6, reflect. Think about all the models and strategies you have discussed today. Describe how one of them helped you better and understand how to solve the try it problem. This is up to you. This is not an answer I can give you. I can tell you personally that the chart is my favorite. I know a very visual learner likes to use the nets, and that's up to you as well. Okay. Remember, your homework, when I say homework, it's really your independent work, is you are going to flip over to page 56. The next page, you're going to do 7, 8, and 9. So 7, 8, 9. Some of these are pretty quick, why there seems to be more. And then you're going to flip over to page 57. And you are going to do, on page 57, I'll make sure I get this correct, I apologize. I want to make sure you do 1 through 5. So 57, you're doing 1, 2. You're going to flip over, do 3, 4, and 5. Bring your journals to class on Monday, and I will check your journals. There is no class kicks this week, just journals.